In this question 3, a line joins 2 points, point A1 and 3, to point B 5 and 8. Find the midpoint of AB. Midpoint, this point here, this one is x1, okay, and this 3 y1, y 4.1, okay, and this 5 here is x2 and 8 is y2. To find the midpoint of between 2 points or midpoint of any line between 2 points, we add x1 plus x2, then divide by 2. This is for x 1 plus 5, x1 plus x2, 1 plus 5, and divide by 2. 1 plus 5 is 6, 6 divided by 2 is 3, so the x coordinate here will be 3. y1 plus y2, 3 plus 8, okay, 3 plus 8 over 2. 3 plus 8 is 11, 11 divided by 2 is 5.5, so the y coordinate here is 5.5. In this part, find the equation of the line AB. Give your answer in the form y equals mx plus c. To find a linear equation of any line, we need to know the gradient of this line and one point on this line, okay? We already know 2 points, okay? Here we need to find out the gradient of this line. Gradient, which noted by m, equals y2 minus y1 over x2 minus x1, okay? This will be equal, y2 here is 8 minus y1 is 3, 8 minus 3, and down x2 minus x1, 5 minus 1, 5 minus 1. This will be equal 8 minus 3 is 5, and 5 over 5 minus 1 is 4, 5 over 4, okay? This is the gradient, m, 5 over 4. And to write the equation, we use this form, y minus y1 equals m times x minus x1, okay, where this m is the gradient 5 over 4. So we can substitute here y minus, we will take any point, take the easy point, okay? If you have a point with negative values, negative coordinates, don't use it, use the easiest point for you, okay? It's 1 and 3, okay? This one is x and 3 is y1, okay? Y minus y1, which is 3, equals m is 5 over 4 times x minus x1 is 1, okay? Try to simplify this here. You can complete your works here, okay? Y minus 3 equals, distribute this 5 quarters between x and minus 1, 5 over 4 times x is 5 over 4x, and 5 over 4 times minus 1 is minus 5 over 4. Now we need to move this minus 3 to the other side by positive value. Here will be y equals 5 over 4x, and calculate this minus 5 over 4, this minus 5 over 4, then this minus 3 will come here, plus 3, okay? Plus 3 equals 7 over 4 plus 7 over 4, and this is your final equation in the form y equals mx plus c. Y equals 5 over 4x plus 7 over 4. In part B, the line AB is transformed to the line PQ. Find the coordinates of P and the coordinates of Q after AB is transformed by a translation by the vector 5 and minus 2. Here we have the points A and B. I already write it here, okay? Translation by vector 5 and minus 2 means 5, take any point and add to x this number on the top, and the number in the bottom add to the y coordinates, okay? It means 5 units to right, then 2 units down, okay? Here we will start with the point A, which be transformed to P, to point P, okay? 5 plus 1 is 6, right here 6. Minus 2 plus, here is 1 plus 5 is 6, okay? 3 plus minus 2 is 1, so the point B is 6 and 1. The same with point B, 5 plus 5 is 10, okay, and 8 plus negative 2 is 6, okay. The second point Q is 10 and 6. A rotation through 90 degrees anticlockwise about the origin, okay. The rotation by 90 degrees anticlockwise, if you have any point x and y, this rotation make it minus y and x. So we need to bring the last number to instead of this first number with inverse sign. So this point here, point A is 1 and 3. We will bring this 3 here in the first with negative sign, okay, because here is positive. So we will start with negative 3 and take this one to the last instead of 3 by it without change any sign, okay. Minus 3 and 1 here, minus 3 and 1, and make the same in point B, 5 and 8. We will bring 8 here by negative 8, then take this 5 instead of 8, negative 8 and 5, okay. In this part, a reflection to these 2 points, a reflection or the line between A and B, okay. A reflection in the line x equal 2. This line x equals 2 is a vertical line across the x-axis on the point 2, okay. So if we draw coordinates like that, okay, this is the line, okay, 2 here. This is the line x equals 2, okay. Here the first point A, 1 and 3, you can find it here, okay. This is point A. Now if we reflect this point in the line x equal 2, we will not, the y value or the y coordinates, which be 3 here, will not change, okay. So we will calculate the distance here between this point A to the line of reflection is 1 unit only, from 1 to 2, because this x coordinate here is 1. Okay, so this point will be here. The image of this point is here, which will be 3 and 3. So the point B here will be 3 and 3. Okay, remember that we didn't change the y coordinates. So in the point B, after reflection in the line x equals 2, we will keep this 8 here, and this 5 will be to the right of the line of reflection by how many units? By 3 units to the right. Okay, so we will reflect it by another 3 units, but this time to the left. Okay, 3 units from this 2 here will be 1, 2 to 0, and will be come here to -1. So the point will be -1 and 8. It's easy. Okay, here in this last part, a transformation by the matrix -1 and 2, 0, -1. Okay, we will multiply this matrix. Okay, -1, 0, 2, -1 by the matrix of the 2 points A and B. Point A is 1 and 3. We will write it like that, 1 and 3. And the second point B is 5 and 8. We will write it here, 5 and 8. Now we have 2 matrices, okay, square matrices. We will multiply. Okay, and don't forget to start with the transformation matrix. Okay, don't inverse the order of 2 matrices. Okay, now the result here will be another square 2 by 2 matrix. Okay, take the first row, multiply by the first column, -1. Okay, we will calculate it here. Okay, -1 times 1 is -1. Okay, then 2 times 3 is 6. So -1 times 1 is -1, plus 2 times 3 is 6, plus 6 equals 5. So we will write 5 here. Okay, now multiply. This number will be found here in the second row and first column. So we will multiply the second row by the first column. 0 times 1 is 0, -1 times 3 is -3. So we will write here -3. Okay, this number will be found here in the first row, second column. First row multiply by the second column. -1 times 5 is -5. Okay, -1 times 5. Okay, then 2 times 8 is 16, so plus 16 is equals 11 here. Okay, and we will multiply the second row by the second column. 0 times 5 is 0, -1 times 8 is -8. Write -8 here. Now we can write the 2 points here. This is the first point, 5 and -3. Okay, 5 -3, and 11 -8 is the second point, Q. 11 and -8. Okay, in part C, describe p42 is a single transformation that maps the line AB onto the line PQ, where P is the point -2 and -6, and Q is the point -10 and -16. Okay, again I already wrote these 2 points A and B here, 1 and 3 and 5 and 8. Okay, if we look at this point here, P, which be the image of A, can find us this coordinates is -2 and -6. Okay, look at here 1 and 3. Okay, here -2 and -6. Okay, this one became -2. Okay, and this 3 became -6. You can note here that we multiplied by -2. 1 times -2 is -2. 3 times -2 is -6. Okay, go to check this multiply by -2 in the second point here. 5 times -2 is -10. 8 times -2 is -16. So the transformation here is an enlargement. Okay, we will write this 3 points. Okay, need to first of all enlargement. Okay, to write the transformation enlargement. Okay, and to this is the first mark here from the 3 mark, and the second mark we need to write the scale factor of enlargement. Sure, it's -2 or -2. We will write -2 here, and the center of enlargement is the origin. We can write here origin. Okay, or you can write the point 0 and 0.